Hi, in this lesson we're going to look at permutations and combinations. This is basically a way of counting options or counting possibilities for certain things. Okay, let's dive in, so I'll show you what I'm talking about. So for the most basic questions, you can see something like this. So from a selection of 5 different cards, how many ways can I pick one card? So really easy, you've got 5 cards, so therefore you have 5 options. Okay, let's make it slightly harder. Same question, same cards, but here I want to pick out 2 cards. Okay, this gets slightly more confusing. So you kind of got 2 main options. One option is called listing. You can list down every possible combination. So I could have Archer then Ranger, I could have Archer then Plague Doctor, I could have Archer then Guardian, I could have Archer then Elite Archer, and so on and so forth. You could do that the whole way through, and if you're really careful, you can work them all out. We're not going to do that. We're going to sort of do it more systematically. We're going to think about this in terms of how many choices do I have. So for my first pick, for my first card, I can pick from any one of 5 cards. So let's write a 5 down there. That there is my first pick. So I have 5 options. Then for my second pick, 1 card is already gone, 1 card is missing. So that means there's only 4 cards left to pick from. So if I have 5 choices for my first pick and 4 for my second pick, that means in total I have 5 options, then 4 options. So I have a total of 20 options. Okay, hope that made sense. However, that's still not the right answer. What I've made here is made a slight oversight. This logic here of doing a first pick then a second pick, you've kind of said right now that if I pick an Archer then a Ranger, that is different than picking a Ranger than an Archer. Okay? Because each of these have a different first pick and a different second pick. So they'll be counted twice. However, because they're the same 2 cards, we want to account for that fact. And it turns out for every possible combination you have, you basically have its opposite combination, where the numbers or the letters are just reversed around. So what we need to do is divide the whole thing by 2. I'll explain more slightly why in a second. But the basic reason is, for every combination we have a mirror of it, which means we basically double counted, so we need to halve our number of options. So we actually have 10 options for different pairs of cards. Okay, let's run with this example a bit further. So here it's basically the same question. I'm going to pick 2 cards, but here I'm giving 1 to Ella and 1 to Suzanne. So let's work it out the exact same way. I'm going to have Ella's card, and I'm going to have Suzanne's. And we're going to work out the options the exact same way. So we're going to say Ella picks first. This doesn't matter, doesn't change anything. It's just one way for us to think about it and get a logical answer. So Ella has 1 of 5 cards to pick from, so she has 5 options. That card is now gone, whatever card it was, so Suzanne only has 4 cards to pick from. So just before, 5 times 4 gives us 20 options. Now here it's a bit different. So before we had to divide by 2 because if we had the cards the other way around, it would still in essence be the same combination. Here that's not true. If Ella gets the Archer and Suzanne gets the Ranger, that is not the same. That's different than if Ella gets the Ranger and Suzanne gets the Archer. These things are different, unique combinations. Okay, appears not be able to spell today. That means we don't need to divide by 2. Because these 2 things are unique, they're different, we just stick at 20 options and we are done. Okay? That's the basic idea for this. What I want to do now is go through basically the whole rules that kind of guide you through this kind of thing. When do I halve, when don't I? So, key rules, if the order does matter. So for example, there's a race of 8 people. How many combinations are the people finishing gold, silver and bronze? So if the order does matter, if it matters who comes first, second and third, then all you need to do is just the number of choices for the first person, times choices for the second person, times choices for the third person. So I have 8 choices for the first person, that person's now gone, so only 7 people left, and I've only 6 people left. And you would just times those together, and that would be your answer. So this is if the order does matter. Let's change it slightly. The exact same question, the exact same race, but here I'm saying the top 3 qualify for sort of a race, whatever. Now I just want to know how many ways can 3 people qualify. So here it's different, because here if you come first, as far as I'm concerned, That's exactly the same as if you come third. There is no difference between coming first or third for this pace. You qualify either way. So here the order does not matter. You don't care if you come first, second or third. So here it changes. You would work out the choices for first, choices for second, choices for third. So just before you would do 8 times 7 times 6. But now you'll need to divide it by the ways you can arrange 3 people. Okay? So basically if I had a group of 3 people with wonderful drawings, how many ways could I sort of arrange them amongst themselves to be the same combination of 3 people? Okay? For this case, this turns out to be 6. Okay? And I'm going to explain where those numbers come from now. Okay? So notation. So ways you can arrange 2 people. If I've got 2 people, that means I've got A and B. I've got a choice of 2 people who comes first. So I've got a choice of 2 for who can come first in my list, and then 1 for who comes second. So they can be arranged 2 different ways. Either A then B or B then A. In maths, writing 2 times 1, we can also write 2 factorial. Okay, I'll come back to that in a second. Ways we can arrange 3 people. So we have people A, B and C, the example we just saw with the runners qualifying. You have 3 choices, A, B or C, for come in first, 2 choices for the next one, because one's gone, and 1 choice for the third, which gives us our 6 choices that I mentioned a second ago. This is the same as 3 factorial. Okay? And if we had n people, so n is any number, we have n choices for the first, then n minus 1 for the second, then n minus 2 for the third, all the way down to 2 and 1. Okay? And we would call this n factorial. Okay? Reason I'm showing you this is that your calculators have that factorial button for you. So if you wanted 5 people organised in any order, you would do 5 factorial. You are looking for a little exclamation point, which you can see is down here in green. So I'm colourblind. So you have to press shift first and then this button to give you that exclamation mark. So 5 factorial is 120. That means if you have 5 people, you can organise them in 120 unique ways. Okay, a lot to take in. What I'm just going to go through now is go through some example questions. So I'll see all that in practice. For every single question, the thing you must ask yourself is, does the order matter? Okay, do we care who comes first, second or third, for example? Okay, first question. From an academy group of 20 footballers, 4 are selected to go to a special training camp. How many ways can we pick this group of 4? So here, I hope you can see that here the order does not matter. We don't care who I pick first, second, third or fourth. They're all going in the same camp and getting the same treatment. So from our previous example, if I skip ahead to the runners, we're basically this kind of question. We want choices for first, choices for second, choices for third, choices for fourth in our case, and then the ways we're going to arrange 4 people. So the first person, I've got 20 choices. The second person, I have 19 choices. Third person, I have 18 choices. And the fourth person, I have 17 choices. So when you've got a big, large group, your numbers always decrease 1 at a time. We then need to divide that by the ways we can arrange those 4 people amongst themselves. So we need to divide it by 4 factorial. Okay, type in your calculator. I'm not going to do it because I'll show you that yourselves. And that will give you the right answer. Okay, different question. So here at a restaurant, there are 8 starters, 11 main courses and 6 desserts. We want to know how many ways Jeff can pick a 3-course meal. So key thing here is, does order matter? Yeah, it does. If I pick a starter, that can also be a main course, and a dessert is just a dessert, it can't be a starter. So I don't need to divide here. Let's work out his choices. So having a 3-course meal, he has 8 choices for his starter, he has 11 choices for main course, and he has 6 choices for his dessert. Okay, times them all together, and that is your answer. Okay, again, I won't bother actually doing it because I'm sure you can do it with a calculator. Let's change it slightly. So in this question, we've got the same menu, and here Spartacus only wants a 2-course meal. So he either wants a starter and a main, or a main and a dessert. And then how many choices does he have overall? For any question like this, where you've got different options, you must do each option separately. So what I mean is, first, I'm going to do a starter and a main course. I'm going to work out how many options he has for a starter and a main course. Once I've done that, I'll then do a main course and a dessert and work out how many options he has for that. So starter in a main course, 8 choices for the starter, 11 choices for the main course. So a total of 88 there. Then for the main and the dessert, I have 11 choices for a main course and 6 choices for a dessert. So that will equal 66. So overall, he's going to have 88 plus 66 choices, which comes out at being 154. Okay, so you must work out each option separately and then add them together if you have more than one way to sort of get his meal or get his whatever the question might be asking. Okay, part C. A group of 4 friends are going to order 4 different starters to share between them. How many options do they have? So here, the order doesn't matter. We don't care who orders what starter because we're all going to share them anyway. So that means we're going to want to do some dividing. So they want 4 different starters. So the first person has 8 choices. Second person, that starter's gone. We can't order the same one again. So there's only 7 choices left, then 6, then 5. And again, because they're sharing them, we have to do the dividing thing. So it doesn't matter which starter this person orders compared to this person, because they're all going to be shared amongst the group anyway. That means we have to divide, and we then divide it by 4 factorial, because there are 4 different starters. And that's it. If they weren't going to share, by the way, it would just be that. You wouldn't bother dividing. Okay, 2 more examples left. A group of 10 people. Every person buys everyone else a present. How many presents are exchanged? So first, let's look at the key question. Let's see if order matters. So I'm going to have person A. He will have to give a present to person B. And that is going to be different from person B giving a present to person A. Okay, they've each got a unique present to give the other person. That means that order does matter. Okay, it matters who gives what to whom, which means we do not need to divide. Okay, so let's work this out. Again, we could label out with numbers A, B, C, and whatever, and label out all the possibilities. But we do the same idea. We want to think about it in choices. So if I just look at anyone given a random present, let's see how many options I've got. So I could have any one of 10 people to give a present, and each of those 10 people has a choice of 9 other people's to give a present to. Okay, so he can't give a present to himself. He can give a present to 9 other people though. So therefore, there are 90 presents exchanged. Because each of the 10 people will give presents to another 9 people. So therefore a total of 90 people. Okay. Last question, pretty much exactly the same idea. A hockey tournament has 10 teams who each play each other once. How many matches will be played? So here, let's see if order does matter. So I'm going to have team A will play team B. Now, is that the same as team B playing team A? And the answer is yes, it is. There's no home or away here. All we know is that each team will play each other team only once. So both of these contain a match between team A and team B. So here we don't care what the order's in. We don't care which team number goes first. That's what the order matter actually means. Okay, both of these is the same match. That means we're going to have to divide. So let's look at the same way as before. Let's pick a random team. I have 10 choices for a team. And each of those 10 teams are going to play 9 matches. They're going to play everyone else, so they're not going to play themselves. So it's going to be 10 times 9. Here, because the order doesn't matter, we don't care which team goes first, we have to divide. And we're going to divide by 2 factorial, which is just 2. Again, the reason is because each match has an identical pair to it with the team names reversed. So we always divide by 2. 10 times 9 is 90. Half of 90 is 45. And that's it. So this is a new topic. It's getting really popular in current GCSEs. So make sure you're fairly confident with it. And as always, this is your key question. You want to think, does the order matter? And that will tell you whether or not you need to divide, which basically makes the whole question either really easy or really hard to get it right or wrong. Okay, I hope that helped. And